Hi everyone, welcome to this Weintek USA tutorial. Today, I'll show you how to connect a PostgreSQL database to an EasyBuilder Pro project using a Node.js API. We'll also walk through the process of requesting and sending data between PostgreSQL and EasyBuilder Pro, providing you with a guide for integrating databases with your HMI. To keep things efficient, I'll be pasting in code from the available GitHub repository and skipping through some of the basic setup steps. The goal of this project is to provide you with a template that you can use to connect your own PostgreSQL database with your Weintek HMI. For this tutorial, you'll need Node.js, PostgreSQL, pgadmin, EasyBuilder Pro, all of which I'll link in the description, along with the project files on the GitHub. Make sure you have a code editor like VS Code ready to manage your code. Lastly, this tutorial includes the use of third-party application and code libraries. While I do my best to explain their functionalities, my explanations are based on my understanding and experience. For the most accurate and up-to-date information, I highly recommend referring to the official documents provided by the creators of the applications and the libraries. Their documentations may contain detailed descriptions, best practices, and potential updates that may not be covered in this tutorial. We will first start off by setting up our PostgreSQL table. For this project, I have one within my server called P1. Within P1, I have a database named machine status. I can view what's within machine status by going under schemas, then table, and then I can right-click to view the table I've made. This will send the query to show the table. As you can see, the columns for this table are ID, product, status, and amount. And they have been populated with some sample values that will illustrate how the values will be transferred later on. Next, we will gather the values needed to connect our API to the database. The values we need can be found by right-clicking on the server, which is P1, and then we can go down to Properties. This will open up a new window, and here we will go under the Connections tab. And for this, we will need the host name/address, the port, and username. I've left the port and username as default values, but hostname and address have been changed to my IPv4 address. I have done this as I have hosted the database on my IP address to allow for my HMI to gather the data later on. But if you want to run it as a local host for now, you can. If you need to find the IP address, you can press ipconfig in your terminal and copy and paste the IPv4 address within this field. If you do this, you also need to configure your Postgres to allow for a new hostname like this. This can be done where the application is downloaded. For me, that's within my C drive. And then go to the version, which is 17, then data. And within the pg_hba_conf file, we need to ensure that hosting is allowed for the IP address. I've set up mine to allow all hosts to connect, but this is not great for security, so you will need to mess around with this a little bit. Furthermore, within the PostgreSQL.conf file, ensure that the listen address is set to the asterisk. This will allow the database to listen to all IP addresses and not block any out. Next, let's set up our Node.js API. This will gather the data from our PostgreSQL database and transfer it to our EasyBuilder Pro project. Ensure that Node.js is installed and set up your environment by running npm init-y and then gathering all the dependencies by doing npm install express pg cores. Next, let's create a file called index.js and copy the code from the GitHub. Within the index.js file, I've imported the necessary dependencies that we have installed earlier. You will not require .env if you have hard-coded your passwords in. I've put this .env in just to protect some passwords, but is not required. The required dependencies are PG for interacting with the PostgreSQL database, Express to create a web server to grab data from. Course library allows connection between the web server and the HMI. Next, we will set up an Express application under the app variable. This will allow requests from the HMI and allow JSON requests as well. Then we will create a client object to fill our credentials to connect with our database. This will be used in the con.connect function to initialize the connection. This will allow our endpoints to have access to the data. I've set up two. One to grab the data within the table, which will be held at the data endpoint, and one will be to grab the amount of indexes in the table, which will be held at count. These endpoints are similar as they execute a query and display the results in a JSON format by going through each of the rows in the JSON. Note that each endpoint is an asynchronous function and utilizes the async and await keywords to ensure that all of the data is gathered before moving on. Lastly, I will start the web server by using the app.listen function at the port and host of my network. I will then use the node index.js to run and host my application. Now we will switch over to EasyBuilder Pro. We'll set up the JavaScript object to request data from our API and display data using the recipe database. For this tutorial, we'll implement the recipe database as this will allow access to the recipe view object. The recipe view object will grow and display the data that we've pulled from the API, and therefore it's flexible and dynamic. Next, navigate to the Data/History tab. I've created a new recipe database here named Placeholder. The recipe database contains fields for the ID, product, status, and amount. All of them are set to ASCII values. However, you can change this configuration as needed. You also might notice that these values have a one-to-one match to the machine status tables columns. This is critical for displaying the data. System registers play a critical role as they hold the interactions for the recipe database. We will focus on two commands, which is 1 to add new records and 4 to delete all records. Therefore, when these values are set to the command register, these actions will be enacted by the recipe object. Next, navigate to the Object tab and click on JavaScript Resource. Here, click Add File and select java_API_request.js, which can be downloaded from the GitHub. This will allow the API request to flow within the JavaScript object later on. Note that when you click on the file path will be displayed on the bottom. When you put additional resources in, this can be a helpful tool to always get the correct path of your resource. Next, go back to the Object tab and select JS Object. Within the Config tab, we will allow access from the JS object to the recipe database. Click on the config, then new value, set a name. For this example, we'll use count, and select the type as address. Under value, set the type as Word and select the corresponding database section. So for this, we'll select on count again. Repeat these steps for ID, product, status, and amount. Furthermore, I will create an object and link it to the command register of the placeholder table. This setup will enable editing, adding, and deleting data in the recipe database while ensuring that the local data in the JS object stays synchronized with the PostgreSQL database. Next, navigate to the Source Code tab. Here, I will paste the code from the EasyBuilder Pro Postgres API recipe.js file. When reviewing this code in VS Code, we first import the JS resource we set up earlier by using the require function and assigning it to the request variable. This variable will be used when making API requests. We also set up a self variable to create a reference to the JS object, declare a count variable to keep track of the number of records in the database. Note that this is a global variable, therefore it can be accessed anywhere. We also store the API host inside a variable for easy retrieval and modification. If using a local host, set localhost inside the string. Otherwise, use the appropriate IP address. Next, we will make the JavaScript object interactive by creating a mouse area object that executes commands when clicked on. When the mouse area object is clicked, it will first set a command value of 4 to the command memory address, clearing all the old data from the recipe database. This ensures a clean slate for the new data that it will be pulling from the API. Next, we will fetch the new data by calling the getCount and getData functions, which will request data from the API. Within the getData function, we create a getRequest using the previously imported JS resource. A try-catch block is used to handle potential errors. The request fetches values from the \data endpoint. Once the data is received, the update fields function is called to process the response. We will get into this function later on. The process for the getCount function is very similar as well. A request is sent to the \count endpoint this time. If the data is retrieved successfully, the update count function is called instead of the update fields function. Otherwise, the catch block will print an error message. Now let's focus on the callback functions that execute after retrieving the data. The update count function starts off by getting the error codes, the API response, and the response body, which contains all the data. The response body is parsed into a variable called data. If no data is retrieved, which is caught in the data.length == 0, an error message will be returned. Otherwise, the number of records in the table, which is pulled from the count endpoint, that will be assigned to the global count variable that we set up earlier. The count is stored in the first index, which is where the 0 comes from, in the JSON.response. And this is held under the count variable. That's where the .count comes from. The update fields function is a little bit different. Since the count has now been updated, we can implement this function as well. This function receives the table data and inserts it into the recipe database. The response body is parsed again for better organization. If the data is empty, the same error message will be logged. A for loop iterates through the database records and inserts them into the recipe database that we set up. Within the loop, we start off by first converting values to strings for compatibility with the setStringData function. We store values from each column, so this includes the ID, product, status, and amount, into their own respective variables. These variables are then inserted into the recipe database using the setStringData function again. This function requires the destination memory, the length of the string, and the data value. A set timeout is also used to allow the data to be properly written before moving on to the next record. The set timeout function takes a callback function and a duration in milliseconds. Therefore, I've also set up a wait function, and all it does is just console.logs waiting. After the wait is over, the command value of 1 is assigned to the command register, which inserts data into the database. These steps are repeated until all records from the PostgreSQL database are inserted. The command is used using the setData function. For the demo of this project, I have placed ASCII objects linked to the recipe database registers and a command ASCII object for clearing the data. A recipe view object is also placed and connected to the placeholders recipe table. To run the simulation, navigate to the Projects tab and select from Offline Simulation. If you encounter issues, double-check your local host and IP configurations. That wraps up this tutorial. I hope this helps you navigate PostgreSQL with EasyBuilder Pro using the Node.js. Don't forget to check out the GitHub repository for source code and documentation. I've also placed other helpful documents in there to help you out on your journey. Thank you for watching.